Good morning, everyone. How are you? Okay, it's not actually good morning, it's good afternoon. Okay, so let how was the paper, Veena? Have you given the exam? How was it? Okay. Can you please tell me what are the scores that you are getting in your previous exams as well? Today's result is not out yet, I think. But what about previous tests? The score you are getting, overall score. Okay, so we will start our discussion. Try to learn the things because this is the nearly the end of the session, I will say. Your exams are approaching. Your exam is approaching, actually, if I say. The question says when a voltage V is equal to something like this is applied to an AC circuit, the current in the circuit is found to be this one. Now, if you see, voltage is given as 200 root 2 sine omega t plus 15 degree. Clear? And current is given as 2 sine omega t plus pi by 4. Now, if you can see here, there is a phase difference. This is omega t plus 15 and this is omega t plus pi by 4. Test not open for me. Why, Logesh? Haven't given the exam today. Only today's exam na, that you can you are not able to give, or all other exams. Okay, there might be a technical issue, I think. You should have contacted during the time of exam so that we can get the solution for you. No problem. Next test, you will be able to, I think you will be able to take the test. So right now, try to solve it with me. Okay, Lokesh. So the question is, there is a phase difference between, we can clearly see that pi by 4 is nothing but 45 degrees. Okay. Now, one more thing you can say here, that power they are asking. Power is what? IRMS into ERMS into cos phi, where phi is what? Phase difference between these two, voltage and current. So if I say phi is what, you can clearly see this is 15, this is 45. So phi is 30 degree. That's we can take from this. Now, one more thing. IRMS is, this is the value of I naught, this is the value of V naught, or you can say E naught, whatever you want to say. So IRMS is I naught by root 2. That is 2 by root 2 into ERMS is V naught by root 2. That is 200 root 2 by root 2 into cos phi. Cos phi is cos 30 and cos 30 is root 3 by 2. Now you can solve this. Root 2 and root 2, 2 will be cancelled. This 2 will become 100. So P will be 100 root 6 watt. 100 root 6 watt. One more thing that I want you to answer, just give me the answer. Looking at these two equations, I am asking you which of the circuit it may be, which AC circuit it may be. Your first option is purely resistive. Second option is purely capacitive circuit. Third option is RC circuit. Fourth option is RL circuit. Which circuit it may be out of these four options? Can anyone answer? Looking at these two equations, V and I, which circuit it may be? If you have any idea, you can say, you can comment the answer. If you have no idea, you can say, no, sir, we have no idea about it, or simply no idea. Stand by, waiting for your response. Purely capacitive. Okay, Veena, listen, listen very carefully. You must remember one or two things. In purely resistive, phase difference is zero. In current and EMF, there is no phase difference. In purely capacitive, phase difference is 90 degree, and current leads the EMF. Remember my word, current leads the EMF. And in purely inductive circuit, phase difference is again 90 and voltage leads the current in purely inductive. Now, the thing is, in this situation, current is leading the voltage. That's for true. That means capacitance should be there. And by only 45 degree, that means it's not pure capacitive. It's not pure capacitive, because in pure capacitive, this phase difference is or should be 90 degree, or must be 90 degree. So this phase difference is not 90. That means circuit is RC circuit. Current is leading. That's why I'm saying that capacitive circuit should be there. But it is not leading by 90 degree. That's why it should be RC circuit. Clear? Okay. Moving further. The lengths of two metallic rods at temperature something theta are LA and LB, and their linear coefficients are something. Okay, that means they are saying there are two rods. These are the two rods. Their lengths are LA and LB. Temperature coefficients are alpha A and alpha B. Clear? At some temperature theta. If the difference in their length is to remain constant at any temperature, then that means they are saying the difference in their length should remain constant. Okay. So one thing that you know, that if I say delta L1, for example, if I am writing it for first rod, delta L1 is equals to alpha L delta theta. Is it clear? This is the equation that we know that. Now for first rod, it is alpha A, this is LA. This is the change in length. If I increase the temperature, the change in length is something. And similarly for length rod, second rod, it is delta L2 is equals to alpha B LB delta theta. I hope you remember the formula that delta L is equals to alpha L delta theta. This is the original form, where L is the original length, alpha is the temperature coefficient of expansion. Now, This is the change in length. So the new length will be new length. Let's suppose it is LA dash. It will be original length plus change in length. So that is LA plus change in length is alpha A LA delta theta. Similarly, new length LB dash is equals to original length, which is LB, plus change in length, which is alpha B LB delta theta. Now they are saying the difference in the length should remain constant. Original difference in their length is LA minus LB. This is the original difference. So the if I say the new difference will be LA dash minus LB dash. This is the new difference. I am subtracting these two equations. So what you will get LA minus LB plus alpha. I am subtracting these two equations, 1 and 2, nothing else. Don't think that what's happening here. Minus alpha B LB delta theta. Now, according to the question, the change in length is constant. That means this new change in length and original change in length are equal. That means they can be cancelled. They are equal, not the difference is equal. That means the term remaining is alpha A L A delta theta is equals to alpha B L B delta theta. Delta theta can be cancelled. Now, which option is correct? Which option is correct according to this relation? LA over LB is equals to alpha B over alpha A. From this relation, you can see that LA over LB is equals to alpha B over alpha A. So, which is option number B. Which is option number B. Moving further. This question you can solve easily. A certain capacitor is charged to a potential difference V. Okay. If its stored energy is to be increased by 2%, then the increase in V is nearly equal to. Now I am saying that energy stored in the capacitor is half CV square. Clear? Now if I say that capacitance is not going to be changed here, if capacitance is not changing, capacitance, they are asking the change in V only. So that means capacitance is not changed. Or capacitance does not depend on the V or Q. It's independent. It depends on the geometrical parameters. So that's not going to change. So that is delta U by U is equals to 2 times delta V by V. C is constant, so it's not going to change. That is 2 times delta V by V. So delta V by V should be, now this delta U by U is 2%, is equals to 2 into delta V by V. So change in potential should be 1%. Nothing else. Which is option number again B. This is a good question. In this question, let's redraw the diagram. Question says two charged capacitors are connected to a cell as shown. These capacitors are already charged. Mark my words. The amount of charge that flows through the cell by the time steady state is reached. Now listen to me. First of all, I am redrawing the diagram. This is first capacitor. This is second capacitor. And this is the battery. Okay. The first, this point is A, B, this is D, this is C. This battery is of 15 volt. Now watch carefully. The first capacitor has, you can see here in this diagram, you can see A is positive, B is negative. That means this 2 microfarad capacitor is charged by 20 volts, out of which terminal A is positive, B is negative. So I am writing these values in this diagram. If potential is 20 volt, capacitance is 2 microfarad, how much charge will be stored on this capacitor? How much charge will be stored in this capacitor? Can anyone say? Charge will be C delta V. Charge will be C delta V. If I say C delta V, then charge will be on first capacitor. It will be Q is equals to 40 microcoulomb. And in this second capacitor, charge will be C delta V. This is charge of first capacitor. Q2 will be C is 3, that is 30 microcoulomb. Clear? Now, and A is positive. That means and A has plus 40 and B has minus 40 microcoulomb charge. Similarly, and D is negative. You can see that. And D is negative. So D has minus 30 and this has plus 30. These are the initial charges that I have mentioned in which color pen? Red color pen. Now with yellow color pen, I am writing the new charges that should be there. The capacitance of first capacitor is 2 microfarad. This is 3 microfarad. Now when you connect the battery, the capacitor, the potential across these two capacitors will become 15 volt. That's for sure, because battery is a forced device and it will force a potential of 15 volt across both the capacitors. Now, if I say the new charge on the first capacitor is 30 microcoulomb, this is minus 30, this is 45, this is minus 45. Clear? Now I have the charge distribution. So what is the charge that is being supplied by the battery? You can say charge supplied by the battery. Final charge minus initial charge. If I do final charge minus initial charge, then we will get the charge supplied. So let's see. That is Q final minus Q initial. In which portion I am talking about? I am talking about in this portion. I am talking about in this portion. So if I say final charges are yellow colored, written color, that is 30 plus 45. That is 30 plus 45. Q initial bar written in red color, that were 40 and 30, which is minus 30. Now you can solve it. This is 75 minus 10, that is 65 microcoulomb. This much charge is being supplied. Is it clear, everyone? Moving further for the next question. This was the good question. Now, a mass of 2 kg is attached to the end of a light, mark my word, to the end of a light rigid rod of length L. Mark the word rod. Pivoted at the other end for rotation in a vertical plane. That means after reading the question, what you can get, that there is going to be a vertical circle motion, vertical circular motion. This is the vertical circular motion. In this Who is rotating? There is a rod. This is a rod. This is the rod which is hinged at one end, and at the other end there is a mass of something 2 kg. Clear? And this is the rod. Rod has no mass, it is light rod. Now it is rotating in a vertical circle. So what are they saying? For completion of the vertical circle, the mass must have at its lowest position a speed of. That means at its lowest position, the speed, let's suppose, is u. And the length of the rod is L. Clear? So if you can see here, when this mass reaches the top end, the rod will be looking something like that. Mass is here and rod of length L. It might be rotated. It may have rotated like this. This is the mass. This is the hinge point and it is rotating, rotating, rotating like this. Clear? So in this situation, if I apply, let's suppose at the highest point, its velocity is v. So if I use v square is equals to u square minus 2g h. So v square is equals to u square minus 2g. And what is the height? Is 2l. Height is what? 2l. Now, the minimum velocity they are talking about, the minimum velocity u that can be given, the minimum velocity at the lowest point. So for velocity to be minimum, what is the condition to complete the vertical circle? That at least at reaching the highest point, the mass, or you can say, if it can reach the maximum height, that means it can reach here. That means if at this point velocity is zero, then the what I am saying that the velocity, initial velocity or lowest point velocity is minimum. So I am putting v equals to 0 here. 0 is equals to u square minus 4gl. So u is equals to root of 4gl. That's the answer, which is option number C. Now again listen, if this was not a rod, there was a string. If there was a string, so mark my words again. If a string was there, for a string in place of rod, this velocity should be, I am talking about minimum velocity, should be 5gl, where L is the length of the string. Where L is the length of the string. So don't get confused by these things. But you should remember that U should be 5gl in case of string. Clear? Moving further. A simple pendulum has a string of length L and bob of mass M. When the bob is at its lowest position, okay, let's draw. Let's suppose this is the simple pendulum. This is the simple pendulum of length L and mass M. It is given the minimum horizontal speed necessary for it to move in a circular path about the point of suspension. This is the point of suspension. Now, what are they saying? They are saying if this is given some horizontal velocity, read out the question again. It is given the minimum horizontal speed necessary for it to complete the circular path. That means the minimum velocity it is given to complete the circular path, or you can say complete the vertical circle. Vertical circle. So in the previous slide, I have told you that minimum velocity for that is root of 5gl. minimum velocity for completing the vertical circle is root 5 GL. That means this much velocity is given. This much velocity is given. When the string is horizontal, the net force on the bob is. Now string becomes horizontal. It is moving. It will move something, something, and after some time it will become horizontal. This is length L. It will become horizontal. So at that time, the net force they are asking. So if I say will be the mg and another force will be the centripetal force. So the resultant of these two forces, this is centripetal force. Resultant of these two forces will be the net force. Clear? So we will try to find out the centripetal force. The process, the think process that should come in our mind, that if we get this centripetal force, this centripetal force is nothing but mv square by r. This is mv square by r. Now we need to calculate the velocity of the ball or the bob when it reaches the horizontal position. When it reaches the horizontal position. Okay, it's very simple. Let's suppose this is our origin, or you can say this is our ground level. We can choose the ground level. Now applying conservation of energy. From conservation of energy, you can say conservation of energy. What is the task that we want to do? We want to calculate the velocity at this point or at the horizontal position. Why? Because if we know the horizontal, we know the velocity at this position, we know the centripetal force. And after knowing centripetal force, we can calculate our answer. So from conservation of energy, we can write K initial plus U initial is equals to K final plus U final. This is mechanical energy initial. This is mechanical energy final. So initially ball is at the ground level and moving with velocity root 5 GL. That means K initial is equals to half. Mass is M. And if I do this velocity square, it will be 5 GL. Plus potential energy, it is at the ground level. That means potential energy is 0. Is equals to K final. Let at this point velocity is something, let's suppose it is U. So it will be easier for you. It is V. So velocity is V, that means half mv square. Plus potential energy is mg, and height of this point is, at this point, height is what? L, mg, L. From the complete equation, you can cancel out m. Clear? Now you need to calculate it. It will be v square by 2 is remaining here. 5 by 2 GL minus GL. Is it clear? You can see the equation. Now it is 5 by 2, 5 minus 2, that is 3 GL. And this 2 and this 2 will be cancelled, is equals to V square. So now we know the velocity is root 3 GL. Velocity is root 3 GL. So the centripetal force will be, centripetal force will be M V square L by R is what? L. When it will revolve in a circular path, the radius will be what? Radius will be the length of the string. So which is L, and L will be cancelled. That is 3 mg. Now the net force will be, you can say one force is, both the forces are perpendicular to each other. So the net force will be under root, you know that parallelogram rule, F net is equals to under root A square plus B square plus 2AB cos theta. So A square means M square G square plus second force is 3 mg square. If you do, that is 9 M square G square. Plus angle between them is 90. So cos 90 is 0. So F net is equals to mg can be taken common, that is mg. Now it will be under root 1 plus 9, that is root 10. So this is going to be our answer. mg root 10, which is option number C, I can say. Root 10 mg. This was a good question. Is it clear? Try to conceptualize the thing that how we are starting the question and how we are ending the question. That will help you out moving further. Okay, this is the question from center of mass. The center of mass of a non-uniform rod of length L. Okay, there is a rod. There is a rod. Okay. Of length L. Okay, it has a length L. And mass density, linear mass density is lambda. Okay. And lambda is variable. That means kx square by L. What does it mean by variable or non-uniform rod? That means if this is our origin, this is our x-axis, this is our y-axis, let's suppose. So if you move towards the positive x-axis, its mass is increasing. Its mass is increasing because you can say that lambda is directly proportional to x square. That means it's becoming heavier, heavier, heavier. Clear? It's becoming heavier if you move towards positive x-axis. It is given. Now we need to calculate its center of mass. Okay. What we know that the center of mass of this rod will be along the x-axis. So x coordinate of center of mass will be what you know the relation. I hope you know that relation. For continuous bodies, it is given as integration x dm divided by integration of dm, where dm is the small elemental particle, the mass of small element. X is its center of mass. Dm is again same thing. So let's take a small element on this rod of length dx at a distance x. I hope you know the derivation of center of mass of a rod. Nothing else. Only lambda is changed. Nothing else. So now if I write x coordinate of center of mass is equals to integration x. Dm is the mass of the small element. This mass of this small element dm. So if I write here, dm is lambda into dx. I hope you know the formula. I hope you know the formula. How you know the lambda is equals to mass per unit length. So mass is equals to lambda into length. So we want to calculate the mass of this small length, which this small length is of what? Dx. So lambda mass is equals to lambda into length, lambda, and length is what? Dx. I think clear. And now value of lambda is also given. So dm will become, lambda is given as kx square by L. That is kx square by L into dx. Clear? Put the values. X, dm is what? Kx square dx by L. Divided by again dm, integration dm is kx square by L dx. Now you can cancel out few things. Constant you can cancel. K can be cancelled with K. L can be cancelled with L. The limits of the integration will be you are thought that means 0 to L. 0 to L. 0 to L. It might be a little bit difficult for you, but I don't think so. So x coordinate of center of mass is what's remaining in the numerator, that is x cube dx. And integration of x cube, anybody knows? Integration of x cube is x raised to the power 4 divided by 4. Limit is 0 to L. Now divided by integration of x square is what? X cube divided by 3. Limit is again 0 to L. In the next step, I will put the limits. So x coordinate of center of mass. You can say 1 by 4 by 1 by 3, that is 3 by 4. Upper limit is L raised to the power 4 minus lower limit, that is 0. I am not writing. That is L cube minus 0. I am not writing. So x coordinate of center of mass is 3 by 4 L. 3 by 4 L, which is option number A. Clear? Moving further. Is this the question that was done in previous class as well? I don't think so. Whatever. But I think so. A spiral spring is initially unstressed. Say yes or no. If it was already done in the previous test discussion. It is first stressed by length x and then again by further length x. The work done in the two cases are W. I hope this is done in the previous test discussion. Say yes or no at least. Moving further. That question was done in the previous class, previous test discussion of 24th April. You can see on the playlist as well. A body of mass m moving with velocity v, okay, makes a head-on collision. That means there is a body of mass m which is moving with some velocity v, makes a head-on elastic collision with another body of mass 2m. Okay, there is another body of mass 2m initially at rest. That means this body was at rest and they make a collision. No problem. Let them collide. The ratio of kinetic energy of a lighter body before and after collision will be. So this is the lighter body. Let's suppose this is body A, this is body B. They will collide. And now let's suppose after the collision, what happens? These bodies are something. This is M. Now this is moving with V1 and this is velocity body V, which is moving with velocity V2. Let's suppose these are the velocities after the collision. Clear? So they are talking about, they are asking the ratio of kinetic energy of lighter body before and after collision. That means if we can calculate this V1, if we can calculate this V1, then we can know the kinetic energy of the body after collision. And before collision, we know that it is half mv square. So our main focus is to calculate V1. Can you decide the focus? What you want to calculate actually? The question, what does it want you to calculate? Now, after understanding what I need to calculate, we can use two things. One is conservation of momentum. Conservation of momentum. That is P initial is equals to P final. This is initial diagram. This is final diagram. Initially, momentum, there are two bodies, but only one body is moving. So initial momentum is M into V. Finally, there are also two bodies, but both are moving. So momentum of first body is mv1 and momentum of second body is 2mv2. Mass is 2m, na? M can be cancelled. So V is equals to V1 plus 2V2. Let's suppose this is equation number 1. How many unknowns are there in this equation? You can say V is given in the question. That means V1 and V2, there are two unknowns. So we have to make one more equation. And one more equation that we need to make, I can make it from the relation that velocity of separation is equals to velocity of approach in case of elastic collision. So what I'm saying, velocity of separation should be equals to velocity of this is the punchline that we have studied in the class of collision. So velocity of separation is what? This is moving with V2, this is moving with V1 in the same direction. So velocity of separation is nothing but V2 minus V1 is equals to velocity of approach. Approach means they with what velocity they are approaching towards each other. So they are approaching with velocity V towards each other. This is equation number 2. Two unknowns, two equation, we can solve it. If I can write the second and first equation close to each other, I will write first equation with V is equals to V1 plus 2V2. This is the first equation. Now we can solve these two equations. We want to calculate V1, so don't try to cancel it out. If I want to calculate V1, then I will cancel V2. So I will multiply 2 in this and subtract these equations. Clear? What I'm trying to do here. I will solve it without making any noise. Okay, so that will be 2V1 and 3V1 minus 3V1 is equals to V. Clear? So V1 is equals to minus V by 3. That means another thing that you can get here, however, it is not asked, not necessary. V1 is equals to minus V by 3. That means the velocity of mass M should be towards left with V by 3 velocity. Now they are asking the ratio of kinetic energy they are asking. So I will write down the ratio for A. They are asking for lighter body. Kinetic energy initial is asking first, before and after cooling. That means initial and after final. K initial is half m v square. K final is half m. Velocity is v1 square. If you see that v1 square is v square by 9. Half m will be cancelled. V square and V square will be cancelled. That is 9 ratio 1. Which is again option number A. Are you able to understand this thing? I hope the question is clear to you. Okay. Another question. In a wire of cross-section radius R, free electrons travel with some drift velocity V. Okay. Let's have a look. Let's suppose this is a wire. And it has some current I. Clear? The radius of cross-section is R. And the drift speed of electron is V. Let's suppose this is electron and it has a drift velocity V. So I am mentioning drift velocity as V or drift velocity as V. Anyone from YouTube can comment which is correct. Which representation of drift velocity is correct? First representation or second representation? Which representation is correct? Very quickly, I will wait for 1 minute only. Or you can say 1 minute is very much. 30-second only. You can comment which is correct representation, 1 or 2 of the drift velocity. Okay, now I will explain. Veena is saying first representation is correct. Very good, Veena. Why first is correct? Because current is opposite to the movement of electrons. So electrons are moving If electrons are moving towards left, then current will be towards right. That's very good. Very good. However, it is not required in the question. Now, another thing that I know, that current is equals to, I have told you, V E N A. This is V now. Current is what? VENA. V is the drift velocity, E is the charge of the electron, N is the number of carriers, and A is the area of cross section. So according to the question, they are saying, what is the current in another wire of half the radius? That means radius is decreasing. Another wire has radius R by 2 of the same material when the drift velocity is 2b. Now I can say that I2 by I1 will be, out of this, E and N are constant. Why constant? Because material is same and electron has same charge universally. So that means V2 over V1 into A2 over A1. Now put the values. I2 over I1 is equals to V2 is what? They want drift velocity to be 2 times, that is 2V over V, into area pi. Second wire has a radius R by 2, that is R square by 4, divided by A1 is what? Pi R square. Pi R square is cancelled. V and V will be cancelled. So what it will be? I2 by I1 will be 1 is to 2. So I2 will be I1 by 2. I1 by 2, that means which option is correct? Option C is correct. Very good. Doable question. The approach is clear. What you can remember? This relation you should remember. Next question. There are 3 charges. You can see the diagram directly. The X component they are asking. The X component of the force on Q1 is proportional to. Okay. Very simple. If I can draw this diagram here, this is our x-axis, this is our y-axis, and this is some another charge Q3. And one charge is Q2, which is plus Q2. This is minus Q1, and this is minus Q3. And this angle is theta. So this is minus Q1. Now, on Q1, they are asking the force. Who will exert force? Q2 and Q3 both will exert the force. So one thing that is very clear, that if I name this force Q2 will attract it. This is the force by Q2. Let's suppose this is F1. And Q3 will repel it. Why repel it? Because Q1 and Q3 both are negative. So Q3 will repel it. So force will be something like that. This is F2. F1 is the force between, I will write here. F1 is the force between Q1 and Q2. F2 is the force between Q1 and Q3. Clear? Now, we can calculate the values of F1 and F2 very easily. What is the value of F1? You know that F1 is equals to nothing but K into product of charges, that is Q1, Q2, divided by separation square. Separation is given as B square. Similarly, F2 will be K into product of charges, that is Q1, Q3, divided by separation is what? A square. After knowing F1 and F2, they are saying X component of force. X component of force, that means you need to do the components here. And if I do the components, what I will get, you can see that this is y-axis. So this angle will also be theta. So this component will be F2 cos theta, and this component will be F2 sine theta. So net force or X component of the force is, I will write here, X component of force is X direction is. There are two forces in X direction. You can see one is F1, another is F2 sine theta. That is F1 plus F2 sine theta. Clear? F1 is Ke Q1 Q2 by B square. This is F1 plus F2 sine theta. F2 is Ke Q1 Q3 by B A square into sine theta. Now they are asking the proportionality, so you can take some constant out of here. What are the constant? Ke and Q1 you can take outside. If you take Ke and Q1 outside this term, it will become Ke Q1 is taken, that is Q2 by B square plus Q3 by A square into sine theta. So force in the X direction or X component of force is proportional to this term, Q2 by E square plus Q3 by A square sine theta, which is option number B. Is it clear? I hope it is. Moving further, I hope we can take one more question. Okay. The question says, an electron, charge and mass is given, is revolving around a fixed proton in circular path of radius r. That means there is a circular path. Okay, it's not very good. About a proton. About a proton. So proton also has charge E, and there is an electron which is revolving. The magnetic field at the center due to the electron is. Now the question is, what are they asking? They are asking the magnetic field at the center. Now the basic approach for solving the question is, going with the answer, what I'm saying, that if electron is moving, let's suppose in this direction electron is moving. Let's suppose electron is moving with some velocity v in this direction. Then current will be opposite to that. Current will be something like that. That means current is being created by the motion of the electron. And if current is creating that, it will form a current carrying circular loop. It will form a current carrying circular loop. And due to a circular loop, field at the center is mu naught I over 2r. Mu naught I over 2r. Or you can say, I will place the r as small because the radius is mentioned as small r. Nothing else. So according to the question, you know the mu naught and 2 is constant. R is given, termed as R, radius is R given. So what is the main focus is to calculate I. Our main focus is to calculate I. So now we will the calculation of I. Okay. Moving further. For the calculation of I will write again current. Let's suppose in one circular loop or in one revolution, I is what? General formula is delta Q over T. So let's suppose this is a cross section So in one revolution, what charge can be transferred from this? That is E divided by time. How much time it takes to complete the revolution? That is time is equals to distance. In one revolution, distance will be 2 by r divided by speed. So now another term that we are not aware of. What is the velocity? That is EV upon 2 pi r. Now current is known as EV upon 2 pi r. Our another prime focus is to calculate the velocity. Now what can we do? We know one more thing, that this is the general thing. Everyone should be aware of those things, that whenever a particle is revolving in a circular path, there must be a centripetal force. And this centripetal force in this particular situation is coming by the electrostatic force between proton and electron. Between proton and electron. So what I will do, centripetal force, that is mv square by r, is equals to, due to the electrostatic force, that is 1 upon 4 pi epsilon naught. If I do the product of charges, both have E charge, that is E square by separation is R square. Is it clear? So V can be calculated, R square, the R can be cancelled. So V is what? Or you can say V is what? 1 by 4 pi epsilon naught E square by R into M, which is under root. This is our velocity. Now place this velocity in equation number 2 and place that I in equation number 1, and you will be done. Now I am trying to place this value. However, it is looking something dangerous, but it's not. From 2, I put the value from 2. I is equals to E upon 2 pi r into V is what? If you do the under root, it will become E over under root 4 pi f. This is I. Clear? Now put this value in equation first. From first, B is equals to mu naught upon 2r. I is what? E square upon 2 pi r under root 4 pi epsilon naught r m. What it will be? Mu naught E square by, you can say this 4 can be taken out. 4, if you take out, it will become 2. So 2 and 2, 4 are already there. 1, 2 is also coming. That is 8 pi r square under root pi epsilon naught rm. Pi epsilon naught rm. You can check the answer which is correct. Mu naught E square 8 pi r square pi m epsilon naught r. Pi m epsilon naught r. Which option is correct? Option B is correct. Okay, which is option number, and this one, this one, this one, this one. Option B is correct. Clear, I hope. So is it done for now? Can we end the session now? It's already 4. We have done a lot of questions, and a lot of questions were also remaining. No problem with that. So I'm ending the session. Bye, everyone.